Okay. Module number 5. A quick note. We will have 2 weeks to complete this module. So next Monday we will not be streaming. We won't be here. But feel free to ask questions away on Discord, even if we don't meet next Monday. This chapter is all about web application. Starting with the usual do I know this? And jumping into one of the most useful protocols when it comes to the web, the HTTP protocol. HTTP 1.1 is defined in RFC 7230 through 7235. It has its 2 definitions of a HTTP server and an HTTP client. The server being anything from like a web server to the client being the browser, a proxy, an API client, or any other custom HTTP client programs. The protocol in and of itself is a simple one. But, as with anything, being simple doesn't just make things easy. It's a good thing and a bad thing. In most cases, HTTP is a stateless protocol. It's not reliant on a persistent connection for communication logic. HTTP transactions consist of a single request from a client to a server, with a single response back. It's the job of the servers to maintain the state of the interaction with the client throughout the transmission of successive commands until the interaction is terminated, which are called sessions. Proxies, HTTP proxies, can act as both the server and the client, as they make requests to web servers on behalf of other clients. Proxies enable HTTP transfer across firewalls, allow for caching of messages, for network address translation, for filtering, and so on. HTTP lives in layer 7 of the OSI model, using TCP as the underlying protocol to transmit messages. When servers and clients communicate, they perform basic interactions based on headers as well as body content. Here is just a snippet that you would see in Wireshark. You must be familiar with what shows up in an HTTP packet, as that will be on the test. One of the things you need to be most familiar in the world of HTTP are the methods. For example, in this packet that is being shown, we have the GET, which retrieves information from the server. There's also head, which is the same as GET, but only returns the headers, no document body. There's the post, sending data back to a server. There is trace, a message loopback test along with path to target resource. There's put, uploading representation of a specified URI. There's delete, options, and connect. The URI and path to resource field represents the path portion of the requested URL. The request version number specifies what version of HTTP is being used by the client. And the user agent is what application is being used. Just looking at this picture, we see that the user, the client, is running on an Ubuntu system, 64-bit, and it looks like they're running Firefox. Here is a response from a server. We see that it's running Apache. In responses from servers, what you need to be well aware of are the status codes. The servers will always respond with a 3-digit status code. The ranges you need to be familiar with. With some of them, you've seen. For example, the 100 series is all informational. The 200s are successful transactions. The 300s are all redirects. The 400, which the most infamous is the 404, are the client errors. And the 500s are the server errors. So once again, if you see a status code of 100 or anything in the hundreds, then it's informational from the server to the client. If you get anything in the 200s, as this picture shows, it is a successful transaction. If you see any 300s, you're being redirected. If you see 400s, the problem is at the client, not at the server. If you see 500s, the problem is at the server, not the client. Now, the different parts of a URL have a meaning to them. The red is the scheme, designating the underlying protocol that's going to be used. It could be HTTP, it could be FTP, it could be S3, it could be GC. It all says what protocol we're going to be using. The blue is the host, and that can be either an IP address or the DNS address of the web server. Next would be the port, designated what exact port we're talking. Next would be the path, from the root directory of the server to the desired resource. Web servers can use aliases, and really should use aliases, to not explicitly give out the root directory. Then will come any path segment parameters, which are optional. And at the end are the query strings. Name and value pairs representing dynamic parameters associated with the request. Now, HTTP 1.1 is not the only one that exists. We do have 2.0. And here you see the difference between the two. Understanding which version of the communication is occurring will help you in understanding how many packets you need to capture to catch the entire transmission. Obviously, any communication using HTTP 1.1 is going to be slower than that of 2.0 because there's less things to do. Web sessions, as I mentioned earlier, include the pre-authentication tasks, the authentication process, the session management, the access control, and session finalization. Web apps create sessions to keep track of anonymous users after the first user request or after the user has authenticated. This allows the app to identify the user on any subsequent requests. Apply an access control lists to increase the usability of the application by using those session IDs or the tokens. Through development framework, it's easy to detect who the user is. Multiple mechanisms exist in HTTP to maintain a session state. Cookies is the most widely used, with the two types being non-persistent and persistent. If a cookie has a max age or expires attribute, it's considered persistent and stored on the disk by the browser until it expires. Most applications, modern ones at least, use non-persistent, which are deleted when the browser is closed. A quick side to the Open Web Application Security Project. OWASP is a nonprofit foundation that focuses on everything web app. If after doing the lab and work for the next 2 weeks, you really feel that this is your jam, I highly suggest becoming a member of OWASP. They have a lot of great talks. There's a lot of useful information. And they're really the forefront leaders when it comes to web application security. Now moving on to some of the more infamous of the vulnerabilities that live in the web. This list has changed. If you have been following my Twitter, not that long ago, I tweeted about the new draft, the new list of the top 10 vulnerabilities in web applications. If you haven't seen that, go check that out. So this list that I will be covering next is still based on the 2017. Obviously, after this, I will have to update it all for the 2021 list. So, SQL is something you need to be familiar with. Like the list of the most common SQL statements. Select to obtain data. Update. Delete. Insert into. Create database. Alter database. Create table. Alter database. Drop table. Create index and drop index. Typically, SQL statements are divided into various categories like data definition language, data manipulation, transaction control, system control, and embedded SQL. Again, having familiarity with SQL, being able to read this and understand what it's saying is important, because SQL injection is everywhere. Here's an example of a SQL attack. We have the website, we have what we're looking for, and then suddenly we have something else that shouldn't really be there. This is causing this to happen. What's called a blind SQL attack. An attacker reconstructs information by sending specific statements and discerning behavior of an application and database. These behaviors could be anything like the 500s or the 400s or even redirects. Again, understanding things like the union operator, joining two queries into a single rule set. Handling things like time delays, where attackers use this when they don't get any input, but they wait a little bit to see the response. Fingerprinting a database to get errors that will be useful. Like here, we see that this is a MySQL application. We have a client error that we can work with. These are good things as an attacker, bad things as a defender. There's SQLi mitigations using either static or immutable queries. Both do not contain data that can be interpreted and thus cause errors or a leak of information. Command line injection vulnerabilities occur when it's possible to run a command that you would normally do in a shell right on the browser. These are not as popular as they used to be because modern application frameworks have better defenses. That is not to say that all websites are protected by it. That is not to say that no website is vulnerable to it. It's still out there, it's just not as prevalent. Authentication-based vulnerabilities exist from using old cryptographic algorithms to downgrading to them. Of course, using weak or known passwords is always an easy target, no matter what you're using. There's also session hijacking, using predicting session tokens in order to get a token of a normal user and get in. It's possible to sniff on the wire for the session. Of course, using encrypted methods will prevent that. And there's also man in the middle or man in the browser. Redirect attacks is also another in this realm of web servers accepting untrusted input that could cause a web app to redirect the request to a URL contained within a untrusted input. It is totally possible to get a server to go to a site that it shouldn't. With authorization-based vulnerabilities, we have parameter pollution. It's a problem if multiple HTTP parameters have the same name. That can cause an application to interpret values incorrectly via input validation, to trigger application errors, modify internal values, or worse. It can lead to either a server or a client-side attack. There's also the insecure direct object reference vulnerability. Occurs when an application does not sanitize user input and doesn't perform appropriate authorization checks. There's the infamous cross-site scripting. Results in the installation or the execution of malicious code, account compromise, session cookie hijacking, revelation or modification of local files, or even site redirection. This picture is showing you the reflected cross-site scripting, or also known as the non-persistent XSS. It occurs when malicious code or scripts are injected by a vulnerable web app using any method that yields a response as part of a valid HTTP request. An example is a user being persuaded to follow a malicious link to a vulnerable server that injects the malicious code in the user's browser. So in this case, the attacker finds a vulnerability on the server. The attacker sends a malicious link to the victim. The victim will click on it. That attack is sent to the vulnerable server. The attack is reflected to the victim and executed, and the victim will send information back to the attacker. Stored cross-site scripting, or otherwise known as a persistent cross-site scripting, is malicious code permanently stored on a vulnerable or a malicious server's database. This can be carried out on things like blog posts, web forums, and other permanent storage methods. There's also the Document Object Model, or DOM, based XSS attacks. Cross-platform and language-independent applications, programming interfaces that treat HTML or XML documents as a tree structure. DOM-based attacks are reflected. Cross-site scripting triggered by sending a link with inputs that are reflected onto the browser. The payload is never sent to the server. It's just processed by the client. We also have the cross-site request forgery, CSRF or XSRF. These occur when unauthorized commands are transmitted from a user that is trusted by the application. This attack is different from cross-site scripting because they exploit the trust that the application has in a browser. In other words, cross-site request forgery affects the application that relies on users' identity. In this blurry example, the URL contains parameters password new equals test and password underscore conf equals test and change equals change a pound. As long as the user follows the link, an attacker can easily send a crafted link to any user to change their password. Next we have clickjacking, otherwise known as the UI redress attack. Using multiple transparent or opaque layers to induce a user to click on a web button or link on a page that they didn't intend to. The user keystrokes can also be clickjacked via CSS style sheets, iframes, and text boxes, fooling the user into entering information or clicking links. The two most common techniques to prevent or mitigate clickjacking, according to OWASP, are to send the proper security policy frame headers to instruct the browser to not allow framing from other domains, and 2, using defensive code in the application to make sure current frame is the top level window. Directory transversal allows attackers access to files and directories that are stored outside the web root folder. A few best practices to fight against this. Understand how the underlying operating system will process file names provided by a user or an application. Never store sensitive configuration files inside the root directory or the web root directory. Prevent any user input when using system calls. Prevent users from supplying all parts of the path. Surround the user input with your path code. And of course, perform input validation by only accepting good input. See, the last point is in relation to this. You can take the hexadecimal ASCII character and recreate the same thing. You don't want an attacker to successfully use this and begin traversing the web server. You want to be able to block these type of things. This next section is all about insecure code practices. Often developers include information in the source code that could provide too much information and be leveraged by an attacker, like system passwords, API keys, or sensitive information. We have the lack of error handling and the overly verbose error handling. This type of weakness and security malpractice provides information to an attacker to help him perform additional targets or additional attacks on the targeted system. Error messages, like codes, database dumps, and stack traces provide valuable information to an attacker, such as potential flaws in the application. Best practice is to handle errors in a well thought out scheme that provides meaningful error messages to the user, diagnostic information to developers, and nothing to the attacker. Hard-coded credentials is a catastrophic flaw. There is no patch for stupid. Please don't hard-code your credentials. There are race conditions, also known as talk to, time of check, to time of use. A system or application will attempt to perform two or more operations at the same time, even though the nature of the system is operations should be done in proper sequence. When an attacker exploits this, when two things are trying to happen at the same time, he has a small window of time between when a security control will take effect and when the attack is performed. Though these are difficult to exploit, it is possible to cause a race condition. A student in one of my classes was successfully able to do a race condition on the mini CTF. There's also unprotected APIs. Look for non-standard parameters and abnormal headers. Determine whether a URL segment has a repeating pattern across other URLs like a number, ID, dates. You can also use fuzzing to find API vulnerabilities. There are a number of best practices, but the idea behind it all is don't have your API facing out to the world without proper security, like using encryption, using strong authentication, making internal API documents mandatory. Don't discuss what you're working on public forums like Stack Overflow. Hidden elements is another way that attackers get data through. These are one ways that CSRF attacks occur. It's also possible to use hidden elements to fight against CSRF. And then the last one is lack of code signing. Using digital signatures to verify the application, the operating system, or any software from modification and execution. Using things like certificates to verify the web server is what it is who it says it is, and the software running is valid. Using things like sub-resource integrity in order to, again, ensure that files are not being modified. And if they are, they won't execute and just be reported. While some of this sounds complicated and some of it sounds easy, it's all necessary. Because all too often, people make infrastructure, like web applications, put it out to the web without proper security, and then get attacked and compromised, and then there's leaks out, and it's all one big nightmare headache that nobody needs, as long as proper security is followed. Any questions? Okay. Well, as I said, next week we are not meeting because, or at least next week there won't be a lecture because we're going to be busy working through the web fundamentals learning path in TryHackMe. The easiest way that I found it is clicking on Learn and finding it right here. You have this weekend next to get through the web fundamentals learning path and submitting the PDF of the completed assignment. As always, if you get stuck in anywhere, ask away on Discord. You are more than welcome to work together. It is not in any way you won't get penalized because you work together. It's always encouraged to work together. But we will be doing some web stuff this weekend next.